Alright, hi people, how are you guys doing? How's everyone? So these are the last few lectures of this series. So I'm glad I started this series 2 months ago and I was able to finish your entire class 11th syllabus in 2 months. So that is quite an achievement. Alright, so let's see. So first of all, guys, let me welcome you to the Unacademy JEE English. As you know, this is a brand new channel by Unacademy, which is India's largest online platform for IIT JEE. And on this channel, everything is being taught to you completely in English. All right, so this is a series that I started hosting about 2 months back, and this was meant for 2020 aspirants. But those aspirants now, hi Ashwin, have their JEE almost around the corner, and we have managed to cover all the topics of class 11th. I've reviewed every topic of class 11th, so hopefully that'll give you their JEE scores a boost. All right, this is the last topic of class 11th. We just finished the discussion in the last class. So today and tomorrow we'll be focusing on problem solving, and we will discuss some advanced level problems today also, and then we will discuss some previous year problems tomorrow. All right, so this is what I have planned for the last two classes. All right, before we get started, let me introduce myself one more time for those of you who don't know me yet. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for IIT JEE offline. So this is the first time I started teaching online. All right, I myself was JEE rank 447, and I've already coached many students to top ranks in IIT JEE in the offline setups. I hope that you guys can also benefit from my experience, and I can coach you guys to top ranks in JEE for your attempts also. So how can you do that? So first you will need to get your Unacademy subscriptions. So what are the benefits of this subscription? So this subscription gives you benefits like live classes. You get to interact with your educators on a regular basis. So in this period of lockdown, when you can't attend your offline classes, so this Unacademy subscription provides you a very great alternative. You have all your classes, all your schedules happening online here. Just like the offline classes, your studies never come to a stop. Alright, plus these classrooms have leaderboards and live polls, which keep these classes highly interactive and fun. So trust me, it will keep you engaged throughout the lecture. Alright, these features ensure that you're engaged throughout the lecture and you're not drifting away somewhere. Next, with this subscription, you will also get access to a test series and you will have analysis sessions for that. So this, as you know, for a competitive exam like JEE is very important. You need regular testing, you need regular inputs, you need regular analysis of where you're going wrong, and that is what your teachers will do for you. Alright, so again, this is a great benefit that you will get for your JEE prep. Next, you have live doubt clearing sessions, which is one of the best features. Again, a lot of students really bother about their doubts keep piling up and they don't know what to do about it then. So in Unacademy courses, every fourth session after 3 sessions of teaching has to be compulsorily a live doubt clearing session. So with Unacademy subscription, your doubts never get piled up. You will never feel the pressure of your doubts not getting answered. All right. And the biggest feature is that when you come in plus. Yes, I am starting my course in plus from first week of October. All right. So what class are you in, Ashwin? What class are you in? All right. So as I was saying, that besides these benefits, one of the biggest benefits that I personally feel is that when you're watching lectures on platforms like YouTube, you have a lot of distractions. There are so many suggestions of videos. So I know YouTube knows how to hook people to their site. So often what happens is that when you're planning to study online and you've come to attend a lecture, you end up wasting a lot of time. That will never happen with your Unacademy subscription, because when you're taking courses on the Unacademy platform, there are no distractions. That platform only has all study related courses only. So it'll be easier for you to avoid those distractions with your Unacademy Plus subscription. Now, on top of all these benefits, your Unacademy subscription gives you the access to India's best educators. So Unacademy is bringing all the top educators of India on a single platform so that you students can study from the best faculties in India from the comfort and safety of your home. Next, so how do you get the subscription? Very easy. First, you need to install the Unacademy app. Once you have done that, you need to go to the plus section in your app. select your goal as IIT JEE and click on that get subscription button. All right. Okay, good, good, good. So what class are you in, Ashwin? So I'll tell you, I'll be starting 2 courses in October. All right. So when you're getting a subscription, you can use this code RD Live. This is my code. This will help you get 10% off on all your subscription fees. So class 11 students should be taking this subscription, which is a 2-year subscription, and 12th and 12th pass students should be getting this. So this is for 12th and 12th pass students. See, the cost of these subscriptions is very, very little. Okay, why Rishabh? Why can't you afford it? Why? See, the 12-month subscription is coming for a very, very less price. And that too, you will get 10% off on this. And you have all sorts of no-cost EMI options for payments. So if you look at the 12-month subscription, it comes for about, what, barely 3,200 a month, with after 10% off would be less than 3,000 a month. See, people are paying more than that for their class 5 and 6 tuitions. All right, here you're getting access to all educators. You will not only pay this amount for physics, you will be paying this amount for your entire IIT JEE preparation. All right. So your physics, chemistry, maths, every subject. If you want to attend some other classes also that are going on Plus, that also you can attend. So the benefits are huge and the cost is not that much. You can also break this payment into no cost EMIs. All right. You can, if you feel this is slightly more, you can go for a 6-month subscription also, I think, because you probably would be taking your JEE in Jan. All right. So 6-month subscription, though per month cost is higher, but overall cost would be lesser. So Rishabh, try if you can afford one of these. All right. Now, in case some of you students cannot afford any of these, then you can always follow us on the JEE English channel. Here we are already providing you free classes, quality content, absolutely free of cost. And to follow us here, you can join us on the Telegram group with the help of the link shown above. All right. So, see, the thing is that the content would be very, very similar. There would be hardly any difference in the content that is being discussed here and that would be discussed in your Unacademy Plus courses. The only difference would be that the amount of problem solving there would be more extensive. There you will get more individual attention and more individual guidance. There you will have regular tests and we will maintain your scores. We will give you regular inputs. Your teachers will tell you, okay, this is the area where you need to improve. So you can study from here also, but that subscription will just give you a smaller edge over those who are not taking that subscription. All right, you are getting individual guidance there. You are getting doubt clearing sessions, regular doubt clearing sessions there. So those are great benefits that you have with that. In any case, if you can't afford that, you can always follow us here where we will be discussing all the theory, all the content from very basics to advanced level. Don't worry. All right, everything is covered here also. So just that you won't get that much of personal attention here. All right, and that much of personal guidance. Sir can take JEE for April without paper 1? Yes, you can. Yes, you can. Absolutely. So all right. So this is the first problem that I wanted to discuss today. This is a problem of SHM where the entire SHM is not allowed to be completed. This kind of problems we did not discuss earlier in SHM. So I thought if I missed a couple of types of categories of questions, so I thought we will discuss that now. So try this. In this question, you've been told a small ball is suspended by a thread of length 1 meter at a point O on the wall, forming an angle, small angle alpha, which is 2 degrees with the vertical. You can see the figure. All right. Then the thread with the ball is deviated through an angle beta, which is 4 degrees, and set free. Assuming the collision of the ball against the wall is perfectly elastic, what is the oscillation period of the pendulum? You can take G equals pi square. Okay, so life is very tough. Why? What happened, no man? Okay, trust me, life will get tougher. At your age, you have hardly seen any hardships. Okay. So, what exactly are you trying to say, Ashwin? I am not sure I follow. Can take JEE for April without paper 1 for BTech. So, paper 1 is usually for BArch. You don't need to take that for BTech, of course. All right, if that was the confusion that you had. And if you meant whether if there are two attempts in Jan and April, can you take the first attempt in April itself? Yes, you can. Okay. All right. So, guys, I would like you to try this problem. I hope everybody is trying this. This is a very good problem, and this is a type of problem that I missed before. All right, I did not discuss. So, do you see hardships और अब तो मजे हैं आपके? All right. So, first of all, trust me, that never happens. No man, that never happens. You will always have some kind of hardships in your life. But yeah, the thing is, obviously, the hardships in my life are relatively lesser because of all the effort that I put in earlier. All right, so obviously the level of hardships changes, and maybe the type of concerns will change for you. So it's better, Ashwin, to write both the papers, the Jan paper and the April paper. Why? Because they only consider the best of the two. All right, if that is what you're asking. All right, so Rishabh is trying. I hope others should also start trying. Noman, so of course, the hardships that I have to face are slightly different and lesser than what others have to face. All right, and yes. See, there is pressure on me also. I also have to work hard in my job. But yes, I can tell you one thing that now, because of all the effort I put in earlier, now for the same amount of hard work, I just earn more than all my school time classmates who did not do that well in their JEE and JEE exams and stuff. All right. So yes, that will make your life slightly easier, definitely. But then trust me, you will have some worry or the other, and the worries and the hardships never go away. Okay. All right. So let's hope others are also trying this. Let us see. Okay. So guys, give me quick answers. Okay. So sorry. I just. All right. I'm still waiting for everyone to try. By the way, I forgot the concept of this question. Okay. So that is why we are discussing these problems. So what will happen? What will happen? Think of it. Let me tell you. This is the kind of SHM where the full SHM is not allowed, right? So imagine two situations. Imagine two situations. In one, there was no wall. All right. In one, there was no wall. Then how would the motion take place? Let us see. So imagine you had this guy. Ah, so you know the time period for this. If it went from beta to beta, you know the time period for this, right? What would be the time period for this? Hello, Moisha. Yes, you are a little late. You wanted problems on truncated SHMs. So I got problem for you. All right. Alternating current problems on an Unacademy app. Okay. Okay. I will plan. See, I was planning to take up class 12th topics next week. And from next week onwards, maybe. All right. So yes, I will discuss maybe magnetism and AC. EMI, magnetism, AC, all those I will discuss next week on the app. Okay. So Moisha, why don't you try this problem and let me know the answer? All right. 2 pi under root L by G. Yes, that would have been the answer for this. Now, the situation that is there is that you have, imagine there was no wall, but you had this line where this angle was alpha. All right. So what if I asked you, what is the time the pendulum takes, supposing it starts from here, it goes till here, it comes back here. So what is the time it takes for this? It would be t by 2, right? For this motion, where t is 2 pi root L over g. Alright. Now, if I asked you, what is the time that it takes from going here to here? You can calculate that also. So imagine when this was passing this, if it was moving with some v. So what will happen? It would have gone all the way here, it would have come back, and when it would have come back, it would have also come back with the same speed v. I hope you realize, while going, if it crosses alpha with a speed v, then while coming back also, it would cross alpha with the same speed v. Alright. Do you follow this? Let me know, do you follow this? Is that fine? Okay. So in the next situation, okay, so till 2 by 2 is fine, but how about this? How about from here to here? Now what happens is that the time from here to here would be the same. The time, imagine now, it takes some t1 time in going from here to here. All right, let's mark it with some other color. Let's imagine from here to here, it takes some time t1, and it takes some time t2 while going from here to here. Then coming back also, it will take time t2, and from here to here, it will take time t1, right? Does that make sense? Now you realize that from here to here, it will take the same amount of time t1, and while coming back also, it will take the same amount of time t1. Why? Because you have been told that it is suffering elastic collisions. So if it goes and hits the wall with v, it will rebound with v only. Alright. So all I need to do is find the value of t1. Alright, find the value of t1, and if I can find t1, then my time period would be t dash in this case. So t dash is the time period for this, t is the time period for this. T dash would be t by 2 plus 2 times t1. Alright. Are you following this? Let me know if you have a confusion about this. I will explain it again. So all I need to do is find the time till t1. Now what I do is I will use the equation of SHM. I know the equation of SHM. X equals a sine omega t. Right. So assuming at t equals 0. So I can write the angular equation similarly. Similarly, I can write angular equation as theta equals beta times sine of omega t. Now assuming that this is t equals 0. If this was t equals 0, if this was t equals 0 and it is going from here to here, then at time t1, the value of theta would be alpha. Okay. So can I say alpha would be equal to beta sine of omega t1. Alright. Yes. So that is how you will solve this. So you have been told that alpha is beta by 2. So this is 2, which would be equal to 4 sine of omega t1. Alright, so what you get from here is sine of omega t1 equals 1 over 2, which means omega t1 equals, okay, sine inverse of this, so pi by 6, or t1 equals pi by 6 omega, which is nothing but 1 by 12 times t. Alright, why? Because t is, as t was 2 pi over omega. So since capital T was 2 pi over omega, I can write t1 as capital T by 12. Okay. So now my time period for the motion that has been asked, t dash, would be capital T by 2 plus 2t1, which is capital T by 2 plus t by 6. So that makes it 2 by 3t. So which means t dash would be 4 pi by 3 root of L over G. That is the answer for this question. Alright, so let me know if everybody followed this. Alright, so tell me, is that fine? Does that make sense? You realize what we did? What we did was that I assumed that the SHM was unhindered. If there was no hindrance, then it would have gone from beta to beta. Alright. And now I know if it starts from here, then in going from here to here, it takes t by 4. If in going from here to alpha 1, it takes some time t1, then while coming back from alpha to mean, it will take time t1 again, and then it will take time t by 4 again. So even if there is a restriction, then all that will happen is it will take t by 4, then t1, then t1, and then t by 4. So the total time period would be t by 2 plus 2 times t1. Now, how to calculate t1? T1 calculation is very easy. Since I know the frequency, since I know the amplitude, I can write the equation of SHM. Equation of SHM would become theta equals beta. Beta would be the amplitude, angular amplitude, into sine omega t. This is imagining that at t equals 0, theta is 0. Alright, so I'm starting from mean. Then if it takes from mean t1 time to reach alpha, then I can say at t equals t1, theta would be equal to alpha. If it is not elastic, then you realize that the period would keep on changing. Then the period of this motion would keep on changing. Then they cannot ask you the period, because every time first it will go up to beta, then it will go up to a smaller angle, then it will go up to a smaller angle, and that is how eventually the SHM would stop. So I hope you realize that it has to be elastic. It has to be elastic. Otherwise, you cannot calculate it, because then the period would not be fixed. Right? I hope you guys followed this. They will have to tell you elastic only. Okay. Alright, AP. Okay, not necessarily. No, not necessarily. It won't exactly be a pure progression. Yeah, but you can't define a period for that. Can you define a period? Can you define a period for such motion? Because every time it takes another time period. So the time taken for every oscillation would be different. Alright, so you can't define a time period. There was a question in advance where they said that the coefficient of elasticity restitution was 2 over 5. Then what they asked was, in how many collisions would the angle become less than certain? Alright, that can be asked. Yes. That is what will happen. Or less than that. It will become not necessarily only 2 degrees, it may become lesser than that also, depending on how much is the coefficient of restitution, right? Total time for a particular oscillation can be found, and depending on the restitution coefficient, as Vanshika has rightly pointed out, there will come a point when the angular deflection will become less than 2 degree. In that case, then it will continue oscillating with that. And finally, the time period would be 2 pi root L by G only. Alright. So I hope you realize what I'm saying. So after some time, yes, it would just oscillate with 2 pi root L by G whenever the amplitude becomes less than 2 degrees. Okay. So yeah, but you can calculate a time of any X oscillation also. Okay. So why don't we try another problem? So in this problem, you've been told two blocks of masses 3 kg and 6 kg rest on a horizontal smooth surface. The 3 kg block is attached to a spring with a spring constant K, which is equal to 900 Newton per meter, which is compressed 2 meter from its equilibrium position as shown in the figure. So This is currently compressed. This is the equilibrium position. It is currently compressed 2 meters. The spring. All right. Now you've been told, okay, the 6 kg mass is at rest and is 1 meter apart from the mean position. Now the 3 kg block is released and it strikes the 6 kg, and after that the two masses stick together. The velocity of the combined masses between immediately after the collision is this, and so these are your options, and the amplitude of the resultant oscillation. Okay, so let me change this because these two options can't be correct. So this was root 2, if I remember it correctly. So one was root 2, one was root of 2.5. Okay, so let's change that. So these are your options. All right, try this. Try this. This is a good problem. All right, let's see some answers. Okay. All right, good. So till the time you guys try this, let me get some more water. My water is getting over and I'm feeling very thirsty. All right, so I'll be right back. Okay. So do I have any answers then? Okay. Let's see what the answers may be. So let me also try A and okay. Okay, so A is one answer that Vanchika is saying. Okay, how about the others? Let's see if A is correct. Hmm. Yes, A is correct. Yes, Vanchika is right. A is correct. Okay, C. Let's see if C is also correct. Okay, so just after the collision, if this is this. Okay, I think I would rather calculate this than solve it mentally. Okay, so Ansab, hi Ansab, how are you? So alright, A is definitely correct. That I checked, that I tried mentally. Okay, and I got the answer as A. Alright, yes. A is the correct answer. I would have to do some more mental calculation for C and D. Let me try. Let me try till the time you guys are also trying this. So okay. Once I know this. Oh, okay. I'm feeling lazy to calculate this mentally. I'm good, answer. How about you? So I'm feeling too lazy to do this mentally. I would rather use a pen and a paper. Uh, okay. Let us see though. So obviously. both the answers are possible because both the answers are less than 2. So there could have been elimination, but that doesn't help me much. Alright, so I will solve. Whenever you guys feel ready for the solution, let me know. Okay. Too much calculation, too much calculation. I'm feeling way too lazy. Okay, so let's still give it a try. Alright, let me know whenever you guys are ready to see the solution. Okay, I am waiting for you guys. Okay, I am waiting for you guys. A and C, okay. So I think all of you are getting it A and C only. So let's just quickly solve this. Same to you, Yasir. How are you? So for the first one, all you need to do is find the velocity here and then apply momentum conservation. So if just before hitting this guy had a velocity u, then I can find that with the help of energy conservation. Yes, 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 I know. So from energy conservation, I can say from energy conservation, from energy conservation, I can say half mv square, half mu square plus half k into 1 square. This would be equal to half k into 2 square, right? So initially the spring had a potential energy of half k 2 square. Then it will have a potential energy left as a half k 1 square, and this difference would have gone into the kinetic energy of the block. Alright, so from here what am I getting? Let's see. So 3 by 2 u square becomes equal to 1 by 2 into 900 into 4 minus 1, which is 3. So 3 by 2 gets cancelled, and you get u as 30 meter per second. Then the moment it collides, they are about to stick. So now I can apply momentum conservation, and from momentum conservation, obviously 3 into 30 would be equal to 3 plus 6 into v. So that gives me my v as 10 meter per second. Alright, so yes, that part is fine. Everybody had answered this. The part A, option A is correct. Now, how about the amplitude? So for amplitude, all you need to do is find the total energy now. So in this case, now, after the two have got stuck, let's write the total energy. So first of all, what would be the omega? Omega would be root k by m. Alright, so root k by m would be root of 900 over 9. That is 10. So first I got the omega as 10. Next, if I want to write my energy, so total energy of SHM. So energy I know would be half into 9, because the entire mass of 9 would be moving with a speed of 100. So this would be the kinetic energy of my system, plus half into 900 into 1 square. This would be the potential energy. So this would be the total mechanical energy after the collision. And this should be equal to half m omega square a square. Alright, so this is from how I will find my a. So you will realize this 1 by 200, 1 by 2, 900 by 2, 900 by 2, 900 by 2, everything gets cancelled. So what you're getting is a equals root 2 meters. So yes, root 2 is right. So yes, Vanshika and Moisha, both you guys got the correct answers. A and C both are correct. Alright, so I did remember correctly and I did change the value fine only. Alright, so let's move on to another question. This is another very good question on SHM. So in this question, you've been told a uniform rod of length L and mass M and mass capital M is pivoted at the center. Its two ends are touching two springs of constants K1 and K2. So please remember, please always pay attention. They are touching, they are not attached, they are not attached to the springs. The ends of the rod are only touching the springs of spring constants K1 and K2. The springs are fixed to rigid supports as shown, and the rod is free to oscillate in the plane shown. Alright, now the rod is gently pushed through a small angle alpha clockwise. So if I'm moving it like this clockwise, okay, so that would be weird. Oh, I think the positioning of springs should be changed. Positioning of springs has to be changed. Yeah, I think this question figure was different. So imagine this being here. This K2 spring is here. Imagine this. Okay. Now if I tilt this by an angle alpha and release it. Advanced PYQ that we will have tomorrow. That we will have tomorrow. This was I think advanced had a similar problem, but I have modified that. I have modified that. Okay. And what problem advanced had was that the springs were attached to this rod, and both the springs had spring constants K. So yes, the figure is from there only. That is why the figure is wrong. I have modified the question slightly. I have modified the question slightly. So in my question, both the springs are on one side only. Okay. And the rod is fixed like this, and both of them have different spring constants. So I hope the situation is clear to all. So at first the rod is gently pushed through a small angle alpha clockwise and then released. You'll find the frequency of oscillations and the maximum anti-clockwise angular displacement. Alright. So it will move like this, end up pushing this spring, then move like this, pushing this spring, move like this, pushing this spring. That is the kind of motion that it will have. No, the springs are attached to the wall. The springs are attached here. Here they are attached. They are just touching the block. Okay, so let's draw this. So this is the ends of the spring. They are just touching the rod. All right, they are not attached. All right, and remove this. So think this is not there. This is not there. This is how the two springs are. Both the springs are on one side only. So if you guys want, I will redraw this. I will redraw this so that it becomes clear to you guys. So let's imagine this is what the situation is. So this is one spring or spring constant K1. This is another spring or spring constant K2. These are massless ideal springs. Okay. So both of them are ideal massless springs only. So this just has a spring constant K2. Now you have a rod. You have a rod which is just touching these. Okay, so imagine this rod. This rod is just touching these springs. Okay. And this rod is pivoted at its center. Alright, let's pivot it at its center. So at its center it is pivoted. Okay, maybe some other color. So yes. At center it is pivoted. This rod has a mass of mass M and length L, and it is free to rotate about this pivot. No, that won't be the answer. The spring constants are K1 and K2. The spring constants are K1 and K2, not the same. No, current electricity is not fully completed. I am still discussing that. I've just started circuit analysis. Okay, so frequency is 1 by 2 pi, 1 by 2 pi or 1 by pi? 1 by 2 pi or 1 by pi? I don't know. Okay, so I don't actually remember this answer, but yeah, I will tell you. And what would be the angle? What would be the angle? So that should be easy. That should be easy. The angle should be easy. Assume no dissipation of energy anywhere, of course. No friction, no dissipated forces present anywhere. Yeah, that's what. That is what I was thinking. No, it won't be alpha. Alpha was the initial angle. If I can turn it clockwise by alpha, when it goes anti-clockwise, the angle would be different. The angle would be different. It won't be alpha. Okay, so let's see. So when this spring is rotated by an angle of theta, then obviously this spring is not attached and only this spring is attached to this, so K2. So it will be applying a force of K2 X2 where X2 would be this, right? So this is what the force it will feel. So if I calculate the torques about C, so first of all X2 would be equal to theta into L by 2, assuming theta tends to 0. So you have been told that they are given small deflections only. Small deflections only. So x2 would be equal to theta L by 2. I can approximate that. Now the torque about taking torques about C. Let's see what we get. We will get that L by 2. I can again roughly approximate this length, vertical length, to be L by 2 only because theta is tending to 0. So L by 2 into K2 x2, which is theta L by 2, this would be equal to 1 by 12 m L square d2 theta over dt2. And obviously there will be a minus sign because the torque would be opposite to the direction of theta. So alright, so from here I can cancel out the L squares and I can cancel out this as 3. So what I am getting is d2 theta by dt2 is 3k2 over m theta. So now you realize that you will get exactly similar thing when this rod is bent like this. You should get exactly the similar equation except that instead of k1 you will have k2. Instead of k2 you will have k1. Now please remember that this half oscillation, so when it goes from here and it comes back here, this half oscillation is happening with the spring K2. This half oscillation will happen with the spring K1. So half the time periods of both would be added to find the total time period. Alright. So if you talk about the total time period, it would be T1 by 2 plus T2 by 2. Alright. So the total time period would be T1 by 2, which would be pi root 3 k1 by m plus pi root 3 k2 by m, and inverse of this, okay. So what you guys have done is slightly wrong. You guys have just added the two omegas. You can't add the omegas, guys. You cannot add the omegas. No. From energy conservation only, it won't be alpha. It won't be alpha from energy conservation only. So guys, what you have done is wrong. You cannot add omegas. You can add time. And then the angular frequency would be inverse of this. Okay. Oh, what am I saying? This I have written wrong. So maybe you will get it. Okay. m by, sorry, 3k1, m by 3k2. So inverse of this, okay, that would be the angular frequency. No, they are not connected. They are not connected. They are not connected. They are just touching. Yes, that is what. This would be the answer, and the angular frequency would be 1 over this. So this is see, I told you I modified it to make it harder only. The question that was asked in IIT was way easier. This is a harder problem. So angular frequency would be 1 over T. Alright. Now from energy conservation. When this angle is alpha and let's say this angle is beta, all the energy of the SHM would be stored in terms of potential energy of the springs. So I can say half K2 into alpha L by 2 whole square should be equal to half K1 into beta L by 2 whole square. Alright, so that is the relation that I will find between alpha and beta. If the rod was connected, then you would have taken torques due to both the springs, okay, Rishabh. Then you would have taken torques due to both the springs. And then you would have got a single SHM equation, then that would have had a single omega. So from here, I hope you will realize that beta would be root K2 over K1 alpha. That would be the other amplitude. Okay. I hope this is clear. Please let me know if this is clear. Did you guys get this? Forget it. Forget it. Let's just write it as 1 by t. Okay, so did everyone follow this? What happened here? Did everyone follow this? So when they are attached, then it is way simpler. When they're just touching, it becomes slightly complicated. Okay. So guys, please let me know if you followed this solution so that I can move on and we can start our discussion on waves. Okay. Thank you. So here, I just wanted to discuss like three really tricky cases of SHM which I missed out earlier. All right, so I already have discussed a lot of SHM cases. So that is it. Our discussion about SHM is over. Now let's get started with waves. So in this problem, you have been told the displacement time graphs of two waves A and B are shown in the figure. Then the ratio of the intensities IA is to IB is. So which one is the correct answer? All right. So tell me, what would be the answer? So the displacement time graphs of two waves. I hope the graph is clear. It is clearly visible. So one wave have wave A has an amplitude of 2A, wave B has an amplitude of A, and you will realize that the time period of B is half the time period of A. All right. So what would be the answer here? What would be the ratio of their intensities? Hurry up. Rest, you can consider that other medium properties are identical. You can consider that these are two waves passing through the same medium. You can think that yes, D is the correct answer. D would be the correct answer. All right, 1:1. So you should remember your intensity. was directly proportional to a square and intensity is directly proportional to nu square. Alright. And you will realize that B has half the amplitude of A, but B has double the frequency of A also. So the answer would be 1:1. Okay. Is that clear? So don't make mistakes in such simple questions, Boysha. This is a fairly simple question. Alright, so tell me if all you guys followed this. Okay. So let's move on to the next one. Here you've been told an organ pipe is closed at one end. Uh, an organ pipe is closed at one end and has a fundamental frequency of this. So okay, let's say and has a fundamental frequency of 1500 hertz. The maximum number of overtones generated by this pipe, which a normal person can hear, is. So you have to give me the answer for that. So let's see. Okay. Something seems wrong. I don't know. Let me try. Okay, this is fine. This is fine. This is fine. C is the correct answer. Yes. Yes. Yeah, so you should take care of that, Marsha. Yes, C is correct. C is correct. All right. So all right. You know that since this is a closed pipe, the frequencies for a closed pipe nu would be 2n plus 1 over C by 4, right? All right, where n would be the number of overtone, right? So no, not 16, not 16. 16th harmonic it would be. It would be 16th harmonic, but overtone has been asked. So where n is the number of overtone? Yes, yes, the answer would be 6, not 16. So this would be nth harmonics frequency. You want that this should be less than equal to 20,000, and this is what your fundamental frequency is. So 2n plus 1 should be less than equal to 20,000 over 1500. So yes, so that is 4, 0 and 3. So this is 13 point something. So 13.33. So 2n plus 1 should be less than equal to 13.33, which means 2n is less than equal to 12.15. So n should be less than equal to 6 point something something. So for up to 6th overtone can be heard by a normal person, 7th overtone will not be heard. Okay. So yes, remember you have been asked the overtone, not the harmonic. If the harmonic was asked, then it would have been the 13th harmonic. Okay. That is why you will see 13 is also in the options. So that just to see if you mark the harmonic or the overtone. So 13th harmonic, however, it would be the 6th overtone. Okay. So everybody followed this? Should we move ahead? If everybody followed this, should we move ahead? Always pay attention. All right. So let's try another question then. Advanced leaves no stone unturned to get us confused and mark the wrong answer. Of course, of course. Of course, even when I am designing a question, I will After writing the correct option, I will think of the three most common mistakes that students can make. Then I will solve the question with those mistakes in mind and then include those in my answers always. They want to check you that if you are in a hurry or not. So trust me, even I make my questions like that. Whenever I am designing a question, trust me, at least two options more would be, if I will think, okay, so where can a student go wrong, which is the most common mistake that a student can make. So I will give that option definitely. So at least two most common mistakes I will give the option. Maybe fourth option I can keep random also, but that is how I will also design a question. All right, that is how you want to test people, because in objective one you have an advantage that you have options from which you get slight hint, but that should have disadvantages also. So if you solve wrongly and you see that option, then you will be happy and you will think, okay, I've solved it correctly. Okay, so Vanshika says 2. Okay, okay, let's see, let's wait for others. So here you've been told, in an experiment to determine the speed of the sound using a resonance column, the length of the air column that resonates in the fundamental mode is this. Okay, so into, okay. Hmm. Yes, that does seem correct. Let's see, let's see. All right, let others also answer. I hope others are also trying. I hope everyone's trying. This should be simple. This is just a few practice problems. All right. Okay. I have to watch basic first. Yes, Rishabh. No problem, no problem. Okay. Okay, so Maisha also says B. So obviously, for the first resonance, if the length is L1, then L1, uh, your frequency of the tuning fork mu would be equal to C over 4 L1 plus E, right? Yes. And for the second length, this would all be equal to 3C over 4 L2 plus E. So all you need to do is equate these two. When you equate these two, let's see what you get. So these will get cancelled, these will get cancelled. You will have L2 plus E equals 3L1 plus 3E. So you will have E equals L2 minus 3L1 over 2. So L2 was 0.35, L1 was zero point 0.1, so over 2, yes. So what you will have, your answer is 0.025 meters. So 2.5 is the correct answer. I also need to watch it from the beginning. Alright, watch all the lectures from the beginning. I have discussed them all. I have discussed all these things. Alright, so B is definitely the correct answer. You guys got that right. Alright, so another question. The intensity of sound from a radio is at a distance of 2 meters from the speaker is 0.025 microwatt per meter square. The loudness at a distance of 10 meters from the speaker would be. So that is what you have to find. Okay. So what would be the loudness if you've been told the intensity at 2 meters away from a speaker? You have to find the loudness at a point which is 10 meters away from the speaker. Okay, let's just quickly try this. So what I wonder what happened to Vineet. Vineet was feeling sad yesterday, and I can't see any messages from him. Vineet, I hope you are doing fine. Okay, okay, that is strange. So I think people realize they haven't studied and they are leaving to watch the previous lectures. Okay, he is in depression. Why? Why? What happened? Why would he be in depression? Okay, that is strange. Just if you talk to him, then tell him to have a word with me. This is not how you prepare. You will obviously find a lot of difficulties, yeah, in your preparation. You can't be going into depression every time you encounter a hurdle. 30 decibel. Okay, okay. Maybe 30 decibel is not in the options. Okay, so maybe you wanna check your calculation again. Otherwise, I will also see. All right. Okay, okay. Let us see. All right. Oh yes, oh yes, oh yes, you are right. You are right. 30 decibel would be the answer. Hmm. 30 decibel would be the answer. I think either I missed a zero or shifted the zero. Yeah, yeah, you are right. The zero should have been here. The decimal. I think the decimal got misplaced while typing, and that is why you don't have that in your options. 30 decibel is correct. All right. The decimal. I think in the question. I think in the original question, the decimal must have been here. All right. While typing, the decimal got shifted. I think. So yes, and the correct answer for this was 40. Otherwise, if the decimal was in the right place, but for the given question, yes, you are right. The answer would be 30. So this is very easy. So I one would be equal to pi over 4 pi into 2 square, and I two would be equal to p over 4 pi into 10 square. So what you will realize is I two would be equal to I one over 25. So that would be 0.001. All right, very simple. Micro watt per meter square. All right. So now that you have the intensity, I took 2m as 1. Okay, yes, so that is wrong. So now that you have the intensity, it is very easy. The loudness would be 10 times log of this is 10 to the power of minus 9 over 10 to the power of minus 12. So that would be 30 decibel. All right. So yes, 30 decibel is the right answer. No, not 4 decibel. Crazy maths. So if the decimal was here, if the decimal was here, then you would have had 40 decibels. Okay. All right. Now you will notice that the options were made of 4 decibel also, just in case you did not multiply it with 10, or maybe I should have made the option 4 bells. Good evening, Seemaji. I am good. This is Shashwat, right? Isn't that Shashwat? All right. Let's try another problem. In this problem, you have been told a plain harmonic wave of frequency 500 hertz. Yes, I figured. So, how is your preparation for advance going? How is your preparation for advance going? Yes, I remember. I remember the ID. All right, why don't you guys try this problem. Okay, good luck, good luck. I hope you're feeling confident. Just take it easy. Try and give your best in the advance. So Sashwat, what was your rank in mains? If I may ask the rank, what was your rank in mains? If you don't mind sharing. So guys, Shashwat did very well in the mains examination. He just took the mains and he has done extremely well. Yes. So very well done, Shashwat. Now try to not slip away from this in your advance. Try and push yourself in top 500. Okay. Trust me. Otherwise, people get lazy. I have that experience. I from 192 I pushed down to 447. So do not let that happen. Push yourself up. Do not become complacent. All right. Good luck. Good luck to you. So if you ever need my help, any kind of help, then please reach out to me. Feel free to reach out. All right. I have been holding these classes on the app, advanced problem solving, but those are mostly previous year problem discussions. So that I'm sure you have already solved. All right. Okay. So a plane harmonic wave of frequency 500 hertz is produced in air with displacement amplitude as 10 microns. Given that the density of air is 1.29 kg per meter cube, the sound of speed is 340 meter per second. The pressure, you have the following options. The pressure amplitude is 13.76 Newton per meter square. Okay, so this should be capital N. This would be Newton per meter square. Okay. Uh, Now the energy density is 0.645 millijoule per meter cube. The energy flux is 0.22 joules per meter square per second, and D only A and C are correct. All right, great to know, Shashwat. Thank you. I hope I can help you better that rank. Okay. All right. Have you guys tried all the other options? Have you guys tried all the other options? Or are you okay? There can be more than one correct, by the way. More than one can be correct. One or more are correct. One or more may be correct. All right. So not necessarily ABC also. All of them could be ABC could also be correct. Just check once. All right. Hmm. So A definitely is correct. Yes, as you all are saying, A is correct. How about B and C? Which of those are correct? All right. Are you guys checking other options or not? फॉर्मूला याद नहीं है. ओके. सो फॉर्मूला याद नहीं भी हो तभी भी होना चाहिए. So okay, as I have told you guys many a times, let me confess one more time. I don't memorize formula myself. I do not memorize formula myself. Just think about it. Think about it. If you have a medium in which wave is traveling, then all the medium particles are performing SHM. All you need to do for your energy density is that find a unit mass. Okay, find some mass. Let's say I have taken mass m. All right. So if I have taken mass m and a wave is passing through this, what would be the total energy of all the particles? It would be half m omega square a square. All right, that would be the energy of SHM. This would be the energy contained here. If I have to find the mass density, energy density, so energy density would be U would be E over volume, which would be half m over volume omega square a square. All right, so half rho omega square a square, that becomes your formula. That's it. Okay. Trust me, even I don't remember these formulae. I never remember these formulae. I never memorize these formulae. You just derive it at that moment. It's very very easy. And when you have to define the flux, then what you do? You think when this in 1 second, let's say this entire thing would shift by C, right? So what is the volume? What is the volume that is getting shifted by C? It would be area of cross section A times C, right? So area of cross section, let's call it S. Let's call the area of cross section S, because A we are already using for amplitude. So the volume that gets shifted, or the new volume that acquires, imagine in 1 second the wave shifts C. So how much volume got more energy? A volume of S into C now has acquired this energy of SHM, right? So energy flux would be nothing but whatever is the new mass that has now got the energy. New mass would be half into m would be rho times a times c into omega square over a square. So energy flux would be 1 over s, this over s, right? You have to find the energy passing through unit cross-sectional area per unit time. So that would be this. So the energy flux formula would become half rho omega square a square c. So trust me, even I did not remember this. I just calculated this. Alright. So now you can check your answers. Half rho omega square a square, and energy flux would be this. Now you can check all the answers. So Moisha, just check for C also. Are you sure C is not correct? Are you sure C is not correct? So I hope now you will remember it. Now you won't have to memorize this. All you have to do is, for energy density, just consider a volume, just consider a mass, alright, in which this wave is propagating. So if any wave propagates through a medium, what happens that all the particles start performing SHM. So all the particles individually would have had an energy of half dm omega square a square. If the total volume of the medium has a mass of m, the total energy contained in that region would be half m omega square a square. As simple as that. Okay. So let's see, if you're saying that this is correct, if I multiply this with 340, am I getting this? If your B is correct, then I guess your C could also be correct. Yes, this is also correct, by the way. All A, B and C are correct. Alright. So just check your calculations. Just check your calculations. The energy flux would be nothing but energy density into C. Okay. You can see it from here. Alright. Did you guys follow this? Tell me. Just substitute the values, find the answers. You will find A, B, C, all three are correct. Alright. Yes, that will happen. Do not make silly mistakes. Trust me, my silly mistakes cost me a 2-digit rank. They just added another digit in my rank. It was so frustrating. Anyhow, so let's have this question. This is another very interesting question. All right. A train approaching a hill at a speed of 40 km per hour sounds a whistle of frequency 580 Hz when it is at a distance of 1 kilometer from a hill. A wind or speed 40 km per hour is blowing in the direction of motion of the train. So the train is approaching the hill, so the wind would also be going towards the hill. All right. Find A, the frequency of the whistle as heard by an observer on the hill, and B, the distance from the hill at which the echo from the hill is heard by the driver and its frequency. All right. So this is also a previous year question, by the way. This is a J question from the advanced, one of the advanced papers, one of the subjective papers. All right. So this is actually a previous year question paper. This I haven't modified. This was decent enough. All right. So try this. So Moisha is already trying. I hope others are as well. And so tomorrow will be the last session of this series, 2020 series. And after that, tomorrow is the last time that I'll see you guys. So tomorrow we'll be discussing some previous year questions. And then I would just wish you all the best. Because this is the last topic of class 11th, and I did not think there is much point starting class 12 topics next Monday when you have your JEE next week itself. All right. So yes. So next Sunday you have your JEE advance, I think. Do we have the time 12th कराने का? 12th कराने का time कहाँ है? When is the advance paper, Moisha? When is the advance? Isn't it on 27th? Isn't it next Sunday? So do you think I can possibly do 12th in 1 week? So I thought there is no point starting something that I could not complete in that time, right? बाकी 12th करवाऊंगा for the next year aspirants. Okay. There is hardly any time, guys. So that was the only issue. So okay, what I will do is I was planning some sessions on the app. Alright, because I have to take some sessions on the app also. So I will plan sessions for magnetism on the app. Okay, I will plan maybe 3 sessions in the next week. Okay, one would be magnetic effects of current. Another would be motion of charges under in magnetic fields, and maybe third I can have maybe EMI. Okay, so three up to 3 sessions I can plan next week. All right. Or we don't have enough time for magnetism and optics both. 1, 2, 3, 4. I hope you realize. So this series was meant for 2020 aspirants, and your advance of 2020 is next Sunday. So what's the point? I can't possibly finish magnetism and optics. Magnetism maybe I will try. Okay, I will try magnetism. I will take a few classes, special classes on the app, free of cost. Those you can attend. Oh, okay. But then what will you do after advance? What will you do after advance? Just relax, enjoy, take some time off from your studies. All right. And whenever you feel like, you can always join my lectures either here or on the app. All right. Okay, so I hope you guys are trying this. So Vanshika says 600 hertz. Okay, so 600 hertz is the frequency that is heard by an observer. All right, how about the distance from the hill at which the echo from hill is heard by the driver and its frequency? So let's try this. So here is your train. It is moving towards a hill. So here is a hill, and initially the distance is 1 kilometer. So the first part is pretty easy. Yeah, 40. 40 km per hour is the speed of the train. Frequency it emits F naught is 580 hertz. All right. We take some interesting discussions like on black hole and some mysteries of physics after advance. Okay, so I will tell you what I actually tried that on the app. Okay, the first special session that I took on the Unacademy app was about relativity, but I did not get a great response. Okay, okay. I was in fact planning to take some special sessions on, let's say, maybe Saturdays or Sundays on YouTube. Maybe regarding somebody was asking about Olympiad level problems. So maybe we can have those discussions. We can discuss some Olympiad level problems, and maybe I can give it a shot. Such discussions, but I don't know how many people would be interested because in my experience and observation, what I notice is that people are not really interested in genuinely discussing physics too much. They just want to know, okay, just tell me how to solve problem, how to get marks in G. That's about it. All right. So I will see what I can do about that. Okay. Don't worry, we will have some sort of sessions. If not that, then definitely NSCP Physics Olympiad problem solving sessions we can obviously have every week. Okay, that is something that I was thinking of. Okay, this series. Again, this series, I spoke to the team also that this series was meant for 2020 only. This series will be ending. I have to take other lectures also elsewhere. So, I'm starting new courses from October also, right? So, on the plus. So, I won't have the time then to take two sessions daily on YouTube also. All right, interactive sessions. Okay. See, I will see what I can do. I will try and do something. If not on a regular basis, then of course once a week or twice a week, definitely I will have a session. So all right, as I was saying, let's talk about this question. So the wind also is flowing in this direction at 40 km per hour. So obviously the speed of sound, C would be taken as 1200 plus 40 for this observer. So here is your observer. For this observer, the C would become this. So 1240. And you have been told that the source is moving with a speed of 40. So what would be the F heard by observer? So let's call that F1. So F1 would be F naught times C over C minus V of source, right? So that would be 580 into 1240 over 1200. So okay, so this is 30, this is 31. Okay, this also goes. Hmm. Okay, सर आपने आईआईटी के डिस्कशंस कर लेना व्यूअर्स बहुत ज़्यादा आएंगे ओके 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 ऑलराइट so let's see 58 into 31 over 3. So yes, this answer is roughly about 600. Roughly about 600. All right. So 599.333 was the answer that I was getting. Yes. So part A, yes, Vanchika has got the right answer. Moisha, you need to check your answer. For the second part is interesting. It says the distance from the hill at which the echo from the hill is heard by the driver. Okay, so let's see. Let's say it hears the echo here at a distance x. So obviously in time t, the wind traveled this distance and this distance, right? So the sound traveled this distance. Now please remember one thing that when the sound is traveling in this direction, its speed would be 1200 when it is traveling in this direction, oh sorry, so its speed would be 1240, and when it is traveling back, its speed would be 1160. I hope you guys took that into account. I hope you guys took that into account, that it will come back with a slower speed. Why? Because the wind itself is moving in that direction. So when you do that, so if let's say after time t the echo is heard, then t would be 1 minus x 1 minus x over 40, and that would be equal to 1 over 1240 plus x over 1160. So you will have to solve this and find the value of x. Okay. So if x is the distance from the hill, alright, all you need to do is solve this expression. So let's see. 1240 upon 40. So that'll be 31. Okay. So I'm getting minus x equals 1 over 31 plus x over 29. Okay. So that gives me, okay, 31 into 29x equals minus times equals 29 plus 31x. Okay, why am I getting my x as negative? Ah, there was 1 here. What did I miss that? Okay. So yeah, this is what you will be getting. So let's see. So basically that would be, on this side you would have 30 into 29 equals, on that side you would have 31 into 30. So yes, your x is coming out to be 29 over 31 kilometer. So 29 over 31. That is 935 meters. Yes, Moisha is correct. So yes, from here you're getting x equals 935.4.5 meters. Alright, so yes, Moisha took care of everything. And the distance calculation is wrong for you, Vanshika. I think you forgot the fact that it would come back with 1160. Okay. Now for the next part, last part, the frequency heard by the driver. So when driver hears the frequency, it would hear roughly 600. So the hill will act as a source of a frequency of 600 hertz. The driver is moving with a speed of 40 kilometer, and the C would be 1160, right? So here the observer is moving. So what would be the frequency? Let's calculate. So let me solve it here only. Nu would be equal to 600 into, this would be this plus this, so 1200 over 1160. Alright, so this would be your answer. So let's see. Okay, no problem. So this would be your answer. So let's see. 600 into 1200 over 1160. So this is coming out to be roughly 621. 620.7 hertz. Alright. So again, both you guys had different answers, 641 and 618. No. So the answer is 621 hertz roughly. Alright, please remember that the speed of sound will be different in both the directions. Alright. In one direction, the speed of air will get added to it. In one direction, obviously, it will get subtracted to it. Okay. So that is why I wanted to discuss this problem. This has that factor of medium moving. Okay. All right. So this is easy. This is also easy. Why don't we discuss one last problem, slightly tougher? Okay, so this is an easy problem. You can try this. होता है जल्दबाजी नहीं करनी नहीं करनी while reading your questions. Always keep a calm mind. Trust me, I learned that the hard way. मैंने जल्दबाजी जेई में की थी अपने. Cost me one digit in my rank. It added one digit in my rank. All right. So this is a standard problem that I wanted you guys to try. So calculate the velocity of sound in a mixture of two gases obtained by mixing M1 and M2 masses of the gases. If the velocity of sound in the two gases individually was C1 and C2 respectively, atomicity of both the gases is same. So okay, this is an easy problem. You guys can try this later. Take a screenshot quick. I want to discuss another problem that is very tricky. So this you can try later. All right, take a screenshot quick. And let me know as soon as if you have taken the screenshot. Okay. I hope you guys have taken a screenshot of this problem. Okay. Next, again, this is another problem that you can try later. This is another standard problem. You can try this later. Abhi, I want to give you another problem, another very good problem to try. See, because there is only 10 minutes left to 11, so that is why. You can try this later. These are two standard type of problems. If you have trouble in solving them, then we can discuss that tomorrow. But today I want you to try another problem which is way more tricky than these two. Okay, so take a screenshot of this and let me know quickly. Okay, hurry up. Take a screenshot, let me know. Then I will move to the problem that I really want to discuss. That problem has been asked in advance also. Or a similar problem had been asked in advance. Okay. So I hope you guys have taken the screenshot of this also, because I am moving ahead. Only 8 minutes left. So this is a problem that I want to discuss. Yeah, this is the last problem that I had saved for the day. So in this problem, you've been told a source of sound of frequency mu naught moves uniformly along a straight line separated from a stationary observer by a distance L. Alright. So the source is moving along a straight line like this, and an observer is here, and the distance between this straight line and the observer is L. Alright. Is the question okay, yes, you can always do that, of course. So source is moving like this. This is how the source is moving. Source is moving along this straight line, and you have been told that observer is standing at a distance of L from this straight line, and you've been told the velocity of the source is eta fraction of the velocity of sound. So source is moving with c over eta, with eta. Okay, this is the speed of source. Alright, now you have to find the frequency received by the observer at the moment when the source is closest to him. Alright, and second, also find the distance between the source and the observer at the moment when the observer receives a frequency nu equals mu naught. Alright, so try this quickly. This would be the last problem that we will discuss today. Alright, so I hope you guys have seen such problems. This problem I think was asked in advance also. I think 2 to 3 years back. So this is a good problem. This is a conceptual problem. This is what tells you how to take the velocities of source and observers and when to take their velocities. Alright, so try this quickly. Till that time, let me look for the answers. I don't even remember the answers. Alright, I hope you guys are trying, by the way. I think this problem was in Erudov also, if I remember. I can't recall. The language is very Erudov type. The fraction neta, that Erudov uses that kind of language a lot. Okay. Okay, you guys try it till the time I am trying to find the answer. Okay, here. Okay. So, okay, it is no, Vanchika, that is not the correct answer. Okay. Hello, Saurabh. So, the answer for the first part, by the way, if I should tell you, so answer for the first part is mu equals mu naught 1 minus meter square. So I think neta is the fraction, by the way. So okay. So it would be neta times c. Neta would be less than 1. The velocity of source would be neta times c, where neta would be less than 1. Because it says neta fraction. Neta is the fraction. So I think yes. Yes, Saurabh, I know. There was a little glitch. Alright, guys. So this is the answer that the question has. So okay. So Moisha, did you just Google the answer? Did you just Google the answer or what? See, because if the answer is like this, then neta has to be less than 1. Right? If neta becomes greater than 1, then obviously the frequency would be negative. So that is why I figured that neta has to be the fraction only, and the speed of source has to be neta times c and not c over neta. In case I told c over neta, then obviously neta would have had been greater than 1. So all right. Okay, so you guys solved it only. Okay. So this is the answer for this first one, and the distance between the source and the observer. So I hope I'll just tell you the logic here, and we will discuss this problem tomorrow because it is already 11 and we are already past 15 minutes over the schedule time. आपने जब बोला था तब टाइप करा. Okay, okay. All right, no problem. No, this is the answer. This is the answer. This is the answer. So I'll tell you the hint, and obviously, so when will the source be closest to the observer? Okay, so obviously the source would have to be here. So when S is here, then the frequency heard by O, however, would be emitted when the source was somewhere here. So let's say source was X here, and then it emits a frequency. Then this distance, sound will take some time. So if sound travels here in time t, in the same time t, the source comes here. All right. So that is what you have to find. If you find this, then you find this theta, and you will take the velocity of source as Vs cos theta. Okay, why don't I just solve this only? Why don't I solve this only? Because since I've told you this much, so let's just solve it. It'll only take 2-3 minutes. So let's imagine the source was some x distance up, and this I already know is L. So I know this distance d. What would d be? D would be x square plus L square's root. Right. So the time t that the sound takes to reach would be d over c, and this would also be equal to x over beta c. All right. So from here I will get a relation between x. I will be able to find x here from here. So let's write this. So if I square both the sides, I will get x square plus over L square over c square would be equal to x square over beta square c square. Right, squaring just squaring both the sides gives me this. All right. So now I can cancel out these c squares, and what I will find is x equals beta L over, it would be 1 minus beta square root. Right. I hope everybody is following this. Once I have x, now the source must have emitted that sound here. If it emitted that sound here, then the velocity of source along the line joining the source and the observer would be v of source. This is along the line joining. Vs would be taken as beta c into cos of this theta, cos theta. So cos of this theta would be x over d square, x over d, right? So Vs would be equal to beta c into x over d. Let's see how much that is. All right, so Vs becomes beta c into x was beta L over 1 minus beta square into 1 by d. Now let's calculate d. So okay. So I can from here only say that d would be this. So from here I can substitute. From here I can substitute x over d would be equal to beta. All right. X over d would be beta. X over d is cos theta. So I can substitute this beta. So Vs would be beta square c. Okay. All right. So that was easy. That was easy. I don't really need to calculate this. I did not even need to calculate that. Turns out. Yes, I did not really need to calculate this also. I could have done without calculating this. Now obviously f would be equal to f naught, and since this is the source that is moving, so c over c minus vs. So obviously this is easy. U naught over, yeah. So this is pretty simple. All right, that would be my answer. All right. I hope you guys followed that. So it turns out I don't even need to calculate d. There was no need. In the second time, I will need to calculate d. In the second time, I will need to calculate d. All right. Just let me know, did you guys follow this? This is very, very easy. So it turns out I really did not need to do all this. This all was not needed. None of this was needed. I could have just simply avoided all this. Wrote from here that this is this, and from here also Vs would be beta square c, and that's it. So F would be mu naught into c over c minus c beta square. That's it. Okay. Next, in the next part, when the source is here, he will emit a sound. Now, this sound, when it reaches the observer, this sound will have the frequency of mu naught. And let's say it reaches it in time t. In time t, it would have moved a distance y. Now, this would be the distance d dash that has been asked of you. Alright. D dash is very, very simple to calculate. All you need to do is find the time. See, you need to remember what has been asked. When observer hears frequency nu naught. So nu naught he will hear if the source emits it here, so that there is no velocity of the source along the line joining them. Alright. So if the source emits a frequency nu naught here, then this, whenever this reaches the observer, he will hear nu naught. And when this reaches the observer, the source would have moved slightly downwards by a distance y. And if I imagine that it happens in t dash time, so I know t dash would be L over C, so which would make my y as L times meta. Alright, so this is very, very simple. So if y is L times meta, I know now d dash would be a root of L square plus L square meta square. So what I'm getting is that the distance between the observer and the source would be L times root of 1 plus meta square. So this would be my second answer. This was my first answer. So both the answers I've got. Okay. Alright, so if everybody followed this, then that is where I would like to wrap it up. We did manage it in 5 minutes. Alright. Okay. So just let me know if you followed this. Just quickly let me know if you followed this. Okay. So that is it. That is where I would like to wrap up today's session. Now, before I go, let me remind you that you guys should be getting your Unacademy subscriptions if you haven't gotten them already. How do you do that? You go to the plus section in your app, you select your goal as IIT JEE, and you click on that get subscription button. Alright, so when you're getting your subscriptions, these are the prices that you have to pay. You can use this code. This is my code RD Live. This code will reduce your subscription fees by 10%. So you get 10% flat off if you use this code while getting your subscriptions. Alright. So again, when you are getting the subscription, use this code. First of all, this cost would reduce by 10%. Second, when you click on proceed to pay, you will get many options of payment where you can break these payments into a lot of no-cost EMIs to lessen the burden of the payment. All right. Yes, I know. I was feeling weird too. This was a new thing for me. For two months, I've been taking classes here regularly. So yes, it feels weird to me also. But I hope I was able to help you guys here, and I was able to help you improve your rank. And I wish you all the best for advance. All right, so I want to give you guys 1 week for your own preparation for your own methods. Okay, so whatever you want to do in one last week, I don't want to interfere with that. So again, if you like today's video, then press the like button, share it with those who can't afford the subscription. So in case you can't afford the subscription, you can always follow us on the Unacademy JEE English channel. Over here, we are providing you high quality content. You will realize from the questions that we are discussing, this is everything that you need to know for advanced level also. All right. So don't worry if you can't afford those subscriptions, then we will take care of you here also. All right. Okay. So trust me, maybe you don't want, but most of the people would want. Don't forget to press the bell icon, and the PDF of all the slides used in today's lectures will be available for download very soon. Alright, for those of you who are following us on the JEE English channel, can connect with us on the Telegram app using the link shown above. Alright, and this is my code. So if you're getting your Unacademy subscriptions, as I was telling you, so you guys have the option of following us on YouTube. What happens in Unacademy Plus courses is that you get more personalized attention. There you have regular structured courses where you have regular classes, regular strength of students who are daily coming, regular discussions of DPPs. So obviously regular tests and discussions, regular doubt clearing sessions. So obviously teaching wise, we are trying to keep the content at par as to what you will get there and what you will get here. There, just you will get more time, more rigorous practice, and more individual attention. All right, so that would be a slight edge. All right, and it would be easier because you are attending all the lectures live. So having a daily discussion. All right, so which usually is not possible on YouTube every time. Okay. Hmm. Okay. So I don't know what you are trying to say. वो YouTube पर नहीं आएंगे फिर. Of course. So who are you talking about? So anyways, so when if you decide to get your Unacademy subscription, if you can afford it, then I think you should get it because the price definitely exceeds is nothing compared to the benefits. The benefits far exceed the price. And use this code, get 10% off. And as I keep saying, this is a highly competitive exam. You will need all kind of help that you can get. You will need every edge that you can manage. So get that edge with your Unacademy subscription. All right. वो लोग जिन्हें एक वीक चाहिए, okay, agreed. Okay, so Saurabh, this is where I would end my session today. You can watch my previous lectures and you will figure out how the graph is. So graph is plotted between kinetic energy and potential energy. You can see the previous lectures. You will find that there. All right, guys. So I will see you next tomorrow. And till then, you take care and keep practicing. All right. Bye bye.